Hey everybody. This video is going to be a breakdown of a Code Sandbox that I've been working on, and it is this game right here that we're looking at. And it's a very, very simple game. It basically is just a shooter where you can, move the ship around, you can change the direction of fire, and then you can shoot some lasers out and hit a couple of enemies, which currently do not do anything except fly directly towards you. So, uh, not the world's funnest game at the moment, but it is a good learning opportunity because it's easy to follow what's happening so far. Um, and it's also hopefully going to be clear to see how we can build from here and start to do some more interesting things like script the enemy paths and maybe make some animations for the destruction of the enemies or load some cool models in for the enemies, all kinds of things. But the way I want to start out here is essentially just break down the scene, show you what the different parts of it are, and explain a little bit about how this is structured so that if you were to go and dive into the code a little bit, you at least have a roadmap um, to point you in the right direction. And like you could probably figure all of this out just by going in there. You don't need the video, but it might help. So let's start by looking at the React 3 fiber canvas element, and then we'll go one at a time through all of the children of the canvas. Because if you're familiar with React 3 fiber at all, you know that the canvas is the top level component. It essentially is going to set up the rendering for the entire scene, which is filling the entire viewport here on the right hand side. So our canvas only has one option. It's black, so that the background is black. Pretty straightforward. But then, where we start to get into the first interesting thing is that the child of the canvas is something called Recoil root. So Recoil root has nothing to do with React 3 Fiber or 3D in general. Recoil root is a part of and an export from the Recoil package, which is a React state management library that you can use for anything. It doesn't have to be used for a 3D scene or a game or anything like that. It could be used for, a business application or um, any web app you can imagine. You can use Recoil. It's basically a way to share state between components in the React app. So, um, a good way for me to explain what that means in practice is by looking at this file gamestate.js. Gamestate.js is where we set up all of the state with something called an atom, which is a part of how Recoil works. And an atom is basically a schema or representation of all the state that is going to be in your app. In our case, we have the ship's position. The ship's position is both the rotation and the XY coordinates of the player ship. And so as it moves around, you can imagine that this value, this state, is changing on every frame. And that's true of some other things like the enemy position, the laser position, and the score. Enemy position and laser position are special because they are arrays. The reason for that is because eventually we're going to have a lot more than one enemy and laser on this. I mean, you already have two enemies and you can have a lot of lasers. So as I fire, I can get quite a few different lasers being tracked at any given moment. As I'm doing this, every single one of these XYZ positions is going to be stored in this state array. And the enemies were previously stored in the enemy position state. In fact, this default value is what is creating the two enemies that we have. So as soon as the app initializes, the state is going to be set to have two enemies and they're going to be positioned at a certain place. Now they're moving towards us, so you might be wondering like how that's happening. We'll get to that in a minute. Just know that this is where we define all the state that our app's going to need. And yeah, so let's see how we use that state next. And in order to look at that, there's a specific component that would be helpful to start with, and that would probably be the R-wing component, which is just the name of the player-controlled ship. And the R-wing component's inside of a suspense component. Suspense is a part of React that gives you an ability to render a fallback component pending the resolution of the loading promise. So until this object, because this is actually, I mean, there are some sprites in here, but this is the only 3D model that's being loaded at the moment. So it is inside of a fallback loader, and that's just going to render until the 3D model gets loaded from the server. But more importantly, if we go to look at the component, you'll see on the first line here, line 70, this bit of code where we're calling a function called use recoil state, and we're calling it with this value, ship position state. So what is ship position state? That is our atom. So this is one of the state items that we want to track. We call use recoil state with that value, which you'll notice we're importing at the top of the file since it's defined in a second file. And then once we have that, oops. Let me just jump back to the ship. Here we are. So yeah, on line 70, we're calling use recoil state. So use recoil state is an export from the recoil package. And what it does is it basically works exactly like use state in React. If you're familiar with React hooks, use state is just a way to store state within a component. So like if we were to do this, and then use state, this would actually give us some state, but that state could only be accessed within the R-wing component. And so you might be thinking like, well, why can't we have state like that where it's only accessible within the ship component? I mean, it seems like we're only using it, as far as you can see here, to set the position of the ship. Why is that even necessary? Why not just set the mouse coordinates directly to the ship position and move it around? That would be possible, except for the fact that we need to know the ship position for the lasers. So when the lasers fire, they are firing off in a specific direction. And the way that we know the direction in this app is basically off of the ship position. We're going to use it to calculate a vector for the firing direction. So like if your ship is down here and it's pointed up there, the laser is going to know what direction to move by looking at this value, the rotation and position of the ship. So to get the ability to share it to the other components, that's why we're using Recoil. Use state would not work for that. We could do it by putting the use state up at a higher level component, or making we could make a provider component to store all the state. We could do all kinds of things, but I found that Recoil actually works really well with the large number of updates that are happening in the app. So you'll notice we're setting the ship position state on every single frame, which is, that's like, I'm not sure what the frame rate is. I don't have a counter on it at the moment, but it's, at least 30 times a second, probably quite a bit more than that. And we're able to smoothly set the ship position, which is great. I really like Recoil for this use. Um, so now let's look at how the lasers grab that ship position value out of state and then determine which direction to fly off. So going back down to our tree, it's not actually the lasers component we want to look at. The lasers component is responsible for rendering all of the lasers once they're created. It follows the same pattern as the enemies component, which is responsible for rendering any enemies that are in state. We actually have a third component called laser controller. And laser controller's only responsibility is to do essentially click handling on the click event so that when we fire, we can create a new laser. So every time I click, a new laser gets added to state, and then you'll notice it starts flying off in a certain direction, but we'll see how that happens later. The laser controller is really only responsible for creating the instance of the laser in state. And that happens right here on line 158. This set lasers is coming from another use recoil state hook, this time with the laser position state. So we already saw use recoil state before with the ship, and we saw how it works, where you have two values that you can deconstruct out of an array. This function returns an array, and then you deconstruct it. That's how use state works too. But it has a getter and a setter, basically. And so we use the setter to set a new value to that. And what we set it to is the current value of lasers, because we don't want to destroy any of the existing lasers here, plus a new laser, which at the moment, and it actually works pretty well, this could change later, but it emits from the very center of the screen. So even if the ship is down here in the corner, the laser actually fires out of the center of the screen. It's kind of hard to notice most times when you're playing, so it simplified things. We could change that, but for now, that's where it comes from. What we're using the ship position for is actually just to create the correct direction so that it matches where your reticle's pointed. You'll notice it goes through the first one and then through the second one and then disappears. And that is happening right here by setting a velocity value on the laser state. And all that's doing is creating, if you remember, a new object in this array, which we defined as our laser position state. It's not causing it to animate at all. If this was the only code we had, we would just end up with a box right in the 0, 0, 0 coordinate, not doing anything. We'll get into next how the laser actually fires. And one more thing to point out is that when we were grabbing the ship position in this component from state, we weren't using use recoil state, we were using use recoil value. Still passing the atom in, but this time it doesn't return an array, it only returns one value, the ship position. And use recoil value is basically for just that case where you don't need to set the value. For example, the laser controller has no business moving the ship around. It just needs to observe it and be notified of any changes to it. So that's when you want to use recoil value instead of use recoil state. So cool. So we've seen a couple things. We've seen how the ship is using use frame to respond to mouse movements and move the ship around. We're seeing how the laser's value is I'm sorry, the laser controller is using that position via recoil to create a laser with a directionality to it. Um, Real quick before we move on to how the animation works, there's one more place that uses recoil value for the ship position, and that is for the the target element here. So the target component is the two red um, fire direction reticles. They are similarly to the lasers being moved around based on where the ship is positioned. So we can go and find those here. Um, yeah, we'll just jump to the definition here and see how that is working. So you know what? I lied to you. I'm actually not using the state for the target. So forget that. The target is doing its own calculation off of the mouse value. And there's some reasons for that. They're not super important though. It just had to do with getting the math right for lining the laser fire up with the reticles. Um, so strike that from the record. No other usage of the ship position. So now let's move on to the animation. Cool. So we saw how the laser controller will create a new laser and state at the 000 coordinate when you click the mouse. So two things here. First off, just because we created it in state, how is it getting displayed on the screen? Well, that's happening in the lasers component. It again uses recoil value, this time for laser position state. It only gets the laser's array. It doesn't modify it at all. And then it maps over it and renders meshes for all the lasers. Wherever state says they are, that's where it's going to render it. There's no animation in here yet, but yeah, we needed to look at this first just to see how they're getting on the screen. So this is how. Rendered at position X, Y, and Z. Cool. So now let's look at how it gets updated. All of the updates for the game. So that means the lasers and then also the enemies which are moving towards us. All of that kind of game logic stuff is in one component here called game timer. And I mean, there might be other ways to do this. This way worked pretty well for me. I just wanted to encapsulate all the game logic in a kind of a state management place, and that's what game timer does. So game timer actually grabs all of the relevant state that it needs and the setters. So it gets the enemies, it gets the lasers, and it gets the score state, which we can talk about in a minute. But since we were looking at the lasers specifically, and also because the enemies and the lasers work in a very similar way, let's look at how lasers is being used in the game timer component. Let's just scroll down a little bit and we'll see here that we're setting the laser position inside of a use frame hook. And just a reminder that a use frame hook in React 3 Fiber is just some code that you want to run on every frame. And that's what we're doing here. So every single frame, and if we needed to for performance reasons, we actually might end up adding some logic in there to skip some frames or only update like every 1 second. But in this case, it works okay. So we're just updating on every frame. And on every frame, we're going to set the laser position to a new value. And because the laser state is an array of laser positions, since there can be more than one, we have to map over the state, the existing state. So like all the lasers that are already out there on the screen, map over them and recreate them, but changing the coordinate values in certain ways. So it always moves away from the player at the same speed, and that's um, just a constant, the laser z velocity, which you can change to make the game feel or play differently. And we'll do that in a later video when we're actually making this a fun game. But for now, just know that the z position always goes out at a specific speed, which if we wanted to look it up, we can scroll to the top of this file and see that it's just 1 unit per frame. But the important part is the x and the y velocity. So how does it go in the right direction in terms of hitting our targeting reticle? Well, that is initialized at the time of firing, if you remember, by the ship position. So we're just calculating like the angle that's necessary given what direction the ship is pointing. And that's what these two values are. And they're stored in sort of like a vector format with just the x and y coordinates. So cool. This set laser position runs every frame, updates every single laser that's in the array and state with new position. And then it does one final thing, which is useful. And that thing is if we shoot a laser directly into the ground, we don't really want to keep track of it forever. As similarly, if we shoot a laser into the distance, we don't want to keep track of it forever. So it cleans itself up at the end with a filter that will remove any lasers in state that are having a z coordinate that are either beyond the laser range we have set as a constant or below the ground height. And that works because the ground is just a plane right now. If we eventually make this ground a little more dynamic and maybe have some generated height map or something, I mean, we can still use that to clean up. The ground height could just be like the lowest possible ground, and that would probably be fine. Or we could get more complicated and have a collision with the ground. But for simplicity's sake, that's how this works right now. When it hits the ground value, it will disappear. And by disappear, I mean the laser state will be set to a new array which no longer contains that value because it's been filtered out. And that's like one of the most important things to know about how this is built, because everything else works in a similar fashion. The set enemies function here is doing almost exactly the same thing, but for all of the enemies that are on screen. So if you remember in the game state, we initialized the enemies array with 2 enemy positions. So when the app mounts, they're there, but then this set enemies function is called in the use frame within the game timer, and it just moves the enemies towards us. Very simple. That is definitely going to change in the next installment of this series. So what I'm planning, I mean, I don't think I'm going to have any fancy AI for this game because first off, I'm not really a professional game developer. This is just for fun and for demo purposes. And also, I think it could be kind of fun without that. I was thinking of maybe making some scripts for the enemies, like a series of different choreographies for them. So like some enemies could fly in really fast from the top, or some could like overtake you and then fly past you and then turn around. Um, Basically, we'll just have a set of keyframes for the enemies, and then instead of just doing one thing, moving them towards you, we'll apply those keyframe velocities and have the enemies do some interesting patterns. But even when it works like that, it'll still be the same idea. We'll just set enemies and then update the coordinates accordingly, and also filter out enemies when they don't need to be on screen anymore. And for the enemies, there's two conditions for that. Either the enemies past you permanently in this case, or they are in this other array called hit enemies. And we'll see that in the final part of this video. So the enemy obviously disappears when the laser hits it. And if you were looking in the console log, you would also see this hit detected message console logged out. That's another function of the game timer. Like I said, for now, pretty much all game logic is in this game timer component. The reason for having this hit enemies array before removing it is mostly just kind of so that we have an opportunity to respond to this, maybe do some logic on it. Right now, it's not doing very much, but basically we're just figuring out all of the enemies that have been hit on any given frame. So we do that by, if there are any enemies on screen, first off, because if there's not, like, there's no point in bothering with this logic. We can map over the enemies and then also basically check if any of the lasers that are on screen are within some distance of that enemy. Just to go a little slower. So the map is going to go and start with the first enemy that's on screen. And then since we have the enemy position now, we can filter on the lasers array and see if any of those lasers have a distance less than 3. And then if there are any lasers, that filter is going to result in an array that has something in it. So the length will be greater than 0. Let's say that 2 lasers somehow, I don't actually know if that's possible at the moment, but 2 lasers were to hit an enemy at the same time. The length of this filter return value would be 2 instead of 1. And we may want to add enemy health or something at some point, and that's when that would start to come in handy. But right now, since we're just going to destroy any enemy that gets hit, as long as any laser intersects with that enemy, we're going to consider it destroyed. Cool. So hit enemies is going to end up with an array of any enemies that have been destroyed. And then we're going to check if we do have any destroyed enemies, and if there are, we're going to increase the score. This logic isn't done yet. This actually wouldn't work if 2 enemies were destroyed on the same frame. It would just count the score as 1. But that's something that we're going to clean up in a later version. Right now, it'll just count your score as +1 and then log that hit detected message that we saw. And then, coming all the way back to our set enemies function, that's where this part comes in. If the enemy that is in state when we are mapping over them is also in the hit enemies array, which means that it has been detected as being hit by a laser. Don't keep it in the list of enemies anymore. Essentially, remove it. And so that's pretty much it. Like that is the important part of how this works. I know if you haven't been exposed to Recoil or you're new to React 3 Fiber, there's a lot here that I didn't really talk about. I just tried to talk about the game part of it. Um, I recommend like doing some React 3 Fiber basic tutorials. There's a lot of good ones out there. I have a couple that are just like how to put an object on the screen and light it and stuff. Um, so maybe check those out. But more importantly, just maybe go into this repository. You go into this code sandbox. You can fork it. You can make changes. You can do things like, what happens if you change the enemy speed to something crazy like 10 and save it. They just fly past you like without even a chance to shoot them. Um, yeah, so there's all kinds of interesting stuff that you could mess around with, and hopefully that will give you a feel for how React 3 Fiber works, how tying state and user controls into your React 3 Fiber scene can, make some really cool stuff possible. Yeah, so get in there, give it a try. I hope this video was, interesting. I know it's just kind of commentary on a code sandbox, but I'll probably be doing some more of them as I build this game out. So I hope you stick around to watch those too. Okay, bye.